KitGuru is about to join a Teams call with Robert Hallock of Intel. I'm in the middle of testing Core Ultra 200S Plus processors, the Ultra 5 250K Plus and the Ultra 7 270K Plus. That was a test of memory. And yesterday I was invited by Intel's PR agency to have a virtual meeting with Robert. I'm not absolutely sure what the conversation is going to be about, clearly about these processors, but quite why Intel wants to have a chat, I don't know. I don't know if they want to ask me how I'm getting on with the processors or to give me more information that might have been handy a week ago when I started benchmarking. But let's find out. So who's going to be the first to make a DLSS 5 joke about cameras and video quality?
You've not clearly. I could use it.
Yeah.
Myself, my name is Erin Mayorino, and I work on the technical marketing side for our desktop CPUs, and really just excited to be able to get to meet people like yourself and talk about our product and see what we can do to help you out as well.
What's the connection between the January 2025, what would you call that, bug fix rework, let's call it a rework, and these plus processors that obviously the embargo for this call lifts at the moment of the reviews, so the audience will be able to pop off and see our reviews and other people's reviews. So is there any connection? What is the connection between those bug fixes from a year ago and these plus updates?
Yeah, absolutely. So with those issues that we had coming with those refresh softwares that we have in January of 2025, we learned a lot. We learned a lot about how our users are getting software. We learned how our users are updating their system. And we want to make sure that our customers, our end users, are seeing the same performance we're seeing in the lab. And through a lot of these different missteps and assumptions that we made, that's kind of how the Intel platform performance package was born. We are trying to simplify and streamline the process to make it a whole heck of a lot easier for users to get that final performance that we're seeing. That way they're not having to go to ODM websites, our websites, Microsoft Store to get the information. They can just simply download this package from our download center, and they should be getting the exact same expected performance that we're getting in our labs as well.
The explanation for that, which wasn't quite what I asked, is that Intel's released a sort of a driver package and software package which appears to do everything in one fell swoop. There's still a certain mystery to me. I'm going to forget the acronym. Intel Application Optimization. I'm getting two nodding heads and Robert Hallock looking steely, so I'm guessing that went well. At the moment, is that software a final version? Obviously, it can be updated, or are we working with a pre-release version? Is that given the release happens on Monday, doesn't it? I'm thinking about little tweaks like a green light to tell you how the thing's functioning or something like that.
Okay, so Intel Application Optimization APO, I believe that was with Alder Lake generation.
Sure.
That is still here.
Right.
It still matters. It's at the operating system level. We generally get about 5 to 10% performance out of it in the games that need support for thread priority, thread execution help, reducing thread count of a game to better fit the hardware. These are all cases that APO can help with. And then there's now this binary optimization tool, which is new in Plus and will be on every desktop CPU going forward. This works at a different level from APO. APO is really about thread scheduling and execution. With binary optimization, we're actually optimizing the machine code of the .exe files and the .dll files of certain games. We are looking for those games to make function calls to the CPU that we have profiled, that we are aware of, that are suboptimally performing on Intel x86. And when we see those function calls in the list of games that we know about in the user interface, we just substitute on the fly the slower version of that machine code for a more optimal, faster version. And by optimal, I mean we have simply reordered how that file is laid out to better fit how our CPU digests machine code at the front end of the pipe. All of those are now wrapped into the Intel platform performance package. And it's this one-stop driver download unified thing that we're debuting for Plus, and again, every platform going forward. And what Aaron alluded to was we kind of had a frail driver situation with the original Arrow Lake, right? You experienced that. We chatted about that. Intel got itself into a position where there were all sorts of valuable platform tools, but they were spread out across different distribution channels. And frankly, it made an unpleasant experience for the enthusiast and clearly led to suboptimal results in reviews. And we have a whole new business team. We have a whole new marketing team. We have a whole new engineering team on desktop gaming. And so we got some permission to think a little differently about how things should work and are supposed to work for enthusiasts. And so I hope that you can see the platform performance package tidies things up pretty neatly. It cleans up a lot of the loose ends that you and I both chatted about last year or earlier this year. And that's kind of the thinking behind the package. So we've got one driver distribution now. We can update it whenever we want. It'll live on intel.com. And anytime we want to publish an update for binary optimization or APO or any other module, it will just be on intel.com. And nobody needs to know Windows Update or ODM website or this download source. It's just one place. That's the goal.
In your technical briefing, which was last week, wasn't it? You used some wording along the lines of the reason that Plus sees gains that the existing Core 200S, Ultra 200S processors do not is because the software has hooks into the Plus hardware that don't exist with the that I've got the wording approximately correct, I believe.
That's right. So binary optimization is on Plus because there are hardware hooks in the physical silicon that allow some of that functionality to occur. Not all of the modules that we have built into binary optimization depend on specific hardware faculties, but some do. Some of the bigger performance gains absolutely do. And so a refresh is a nice opportunity to bring in small changes like that don't fundamentally alter the performance, but can open up a new path of optimization. And so that's part of the reason why it's difficult to bring binary optimization backwards to older silicon, because all the hardware hooks aren't there, right? It would be a very different experience, a very different outcome. We're looking into it, but we can't commit because we don't really know yet until we look at it.
So we can describe Plus, the process node at TSMC on the CPU part hasn't changed. The architecture hasn't changed. This is tweaks that have enabled these updates, the Plus updates, to come to life.
It's a little bit of both. What I don't think I know you know this, but what users probably don't know is that when you see a process technology in a given name, like Intel 18A or TSMC N3B, that is actually just a family of process technologies. And over time, the recipe to produce that technology gets better and better. And that is in the industry called a BKM, the process BKM. And so these are like small tweaks that can increase frequency, drive down power. And if you produce a new CPU later in the life cycle of that process node, you can take a newer BKM and get some extra frequency and lower power out of it. In addition, you can make small tweaks to the clock circuits in the architecture itself to also extract more frequency. So you'll see that in the SoC tile for the die-to-die. You'll see that in the compute tile for its die-to-die link to the I/O tile. You'll see it in the ring frequency. And these are not major architectural changes, but there's something small that does have to change to produce a higher frequency. It could be clock trees, it could be layouts. I can't get into specifics, of course, but anytime you see an increase in frequency at the same TDP, you can pretty much guarantee that there's a BKM adoption, a newer one, plus some small tweak inside the silicon to make it possible.
Let's look back to my actual list of questions I sent you. Good,
let's do it.
Yeah, I said Intel has now successfully, or will in a few days' time, delivered mainstream processors and motherboards However, AMD still has a significant edge in gaming, specifically, obviously, the 3D AMD. Is that a situation that Intel just has to accept in 2026? Or to put it another way, Ryzen 7 9850X 3D is the gaming king for the DIY market. Is that just a fact for the rest of this year or not?
I think it's all about what people have to spend at the bottom line, right? It's about budgets. And if you have $500 to spend on a CPU, yes, the 9800X 3D, it's about 10% faster than the 270K, roughly, at 1080p. Whether or not 10% is worth $200-300 extra dollars, that's not for me to decide. That's for users to decide. That's for budgets. I hope you will agree, though, that at $200 and $300, there hasn't been a lot of innovation in a while. Not a lot of great choices. Usually just old stuff priced down to a lower price. Nothing new has been happening. And that is something we specifically wanted to address with Plus. We don't have the fastest gaming CPU right now, but we are extremely close for a pretty fair chunk less that you could allocate to, I don't know, memory or cooler or power supply, a case, right? That is a meaningful amount of money back in your pocket. And that's our thinking, right? We have the technology to do this slice of the market really, really well this year. And that's what we're moving forward with.
The question I would love to put in there to the audience is, because the Core Ultra 5 is essentially now a Core Ultra 7, the Core Ultra 7 is essentially a Core Ultra 9. I struggle to understand how Intel can make money now at those prices with those parts, but there's no way I can think to ask the question that will get any form of answer from the three people on the other end of this call, sadly. That's what I'd like to ask you, but I shan't because it's early in the morning in America. Next question, CU-DIMMs. When the Core Ultra 200S arrived for review end of 2024, I received CU-DIMM's memory at the time, and when they arrived, I had no idea what they were. I didn't know how to pronounce. I didn't know if it's CUDIMM, CU-DIMMs, or I'd never heard of the things. It felt like it was an invention brought into play to get extra clock speed from memory to help the processor along the way, which may or may not have been a good idea. Is CU-DIMMs, in your opinion, a legitimate mainstream technology, or you've now announced support for high-capacity 4-rank CU-DIMMs, and we saw that at CES. MSI had a motherboard with A-data. So is CU-DIMMs, having appeared, now going to head off and be a niche product for specific applications, or is it a mainstream product for Intel?
It's fuzzy. That's a very interesting question. Okay. So let's start with the official JetX spec. That's a good place to start. The official JetX spec says that if you're going to produce a DDR5 module at 6400 MTS or higher, it must be a CU-DIMM. That's the official spec.
I didn't know that.
Because,
okay.
Yeah. Because to guarantee widespread compatibility, like boots on anything, 6400, it's got to have a CKD chip on the module. However, I think we all know that those specifications are very, very conservative for all sorts of reasons that are not really applicable to the PC enthusiast market, but still must be comprehended in the spec itself. Okay, so now you're in this position where, let's say we're Intel, we have a fantastic memory controller with all sorts of extra headroom and guard band and margin that is not anticipated by the official spec. In that case, you may not even need a CU-DIMM. There are plenty of 7200, 8000, 8400 modules on the market for Intel that do not have a CKD at all. But when you start adding more memory ranks and more density, more capacity, kind of doesn't matter how good your memory controller is. It becomes extraordinarily difficult to host that capacity at speeds that people would actually want to use in an enthusiast PC. And that's why quad rank CU-DIMM, I think, is a very interesting technology, although very new. I'll acknowledge that. Not a mainstream tech this year. But you get all the capacity, all the bandwidth, great memory timings. You basically get a HEDT level capacity, but at more traditional mainstream desktop transfer rates and performance in games. Pretty cool. Now, I won't say that those modules are cheap right now. They're certainly not. But CU-DIMM is taking on, as a technology, be it dual rank CU-DIMM, single rank CU-DIMM, quad rank, whatever flavor of CU-DIMM you want. They are increasing in prominence over time because the CKD chips themselves are relatively inexpensive for both the vendor and the consumer in a normal world. And it very much has positive benefits for latency, for timing, for data integrity. Having that CKD chip really does help in some cases. But again, if you have a great memory controller and you're only running 32 gigs or 48 gigs of RAM, you may or may not need the CKD. And so that's where it gets a bit fuzzy. I hope that answers your question.
It does. Taking some of what you just said and turning it the other way around, with the original launch of Core Ultra 200S, latency and unpredictable latency was something I experienced. I think I mentioned this to you a year and a bit ago, jumping from sort of 80-something nanoseconds to 180 nanoseconds. Was that anything to do with CU-DIMMs or nothing to do with CU-DIMMs?
Nothing. In our final analysis, what we learned back then was there were certain very, very important performance and power settings that were supposed to be delivered via Windows Update that were not delivered on time for you as a reviewer or for users purchasing that thing in the public for the first few weeks. And you may have seen an allusion in the press deck to the OS PPM file.
Yes.
That's a Windows file. You know it as balanced and high performance. We've all seen those power plans and sliders, but what that's actually tuning is core parking, thread selection, boost frequencies, power targets, and every vendor for every CPU customizes those out-of-box values. But if you don't have that file, then the scheduler might be making the wrong thread scheduling decisions. It might be parking cores that you actually need to be awake for memory latency reasons. And so now you're incurring penalties for migrating a thread from one core to another because you made a mistake, or you're incurring a penalty because you had to wake up a core that wasn't supposed to be asleep in the first place. And that's what happens when you don't have the software tidy and in order to demonstrate the correct capability of the product. So that is another reason why we have the Intel Platform Performance Package and why the latency should be much more consistent. It was purely down to software not being there to make the right scheduling calls or the right core parking calls.
And if I recall correctly, last week you said in the briefing, you can choose balanced or high power modes as you see fit because they're the same.
Yeah.
I think that's so. Is that a change that Windows doesn't really care which you choose? It's a switch you can flick, but it makes no difference on this platform.
It makes no difference on this platform. Our original thinking with Arrow Lake, the first ones, is that we want, like, the intent of these power sliders is to, we wanted to respect the intent from Microsoft. Right? There is an intent here that if you move that slider, the processor gets more quiescent, consumes less power, is intentionally a little more lazy on boost to be conservative. But what we found is more often than not that most desktop people don't even know that this slider exists or don't even care to touch it. And so this time we're like, you know what? We're just going to make the out-of-box default the best possible experience so people don't even have to know about this stuff. And we are not the only vendor that has made that decision for exactly this reason.
And there are so many vendors. I believe I'm right in saying with the mobile platforms, with laptops, that the power plan affects thread director and whether it starts with a P core and moves to an E core, or starts with an E core and moves to a P core. Does that same thinking apply on the desktop, or is that something you've essentially moved away from as fast as you possibly can?
That's more of a mobile taxonomy. We want to start with e-cores first on mobile if possible, because the performance counters suggest that's the right thing to do. We take the opposite approach on all of the high performance gaming chips, including HX, for example. You start with P-core first and then migrate down. And that is kind of the standard default for our gaming CPUs.
And the fourth and final question I have the lessons from Arrow Lake 200S Plus helped the development of Novalake, assuming you have something to do with Novalake? I don't actually know that. Or has the process for getting Plus into life actually taken resources from Novalake development?
Let's see, what part of that can I answer? I will say that Arrow Lake as a technology, as a family, had a lot of influence on Intel internally. Its processes, its procedures, what teams are handling these products. Our desktop gaming group has new engineering, new marketing, new business team, new software engineers. Right? We've recomposed all of those teams inside the company to better drive the performance roadmap forward for gamers. That's what I can say. I think people, gamers, users, reviewers want Intel to be a certain kind of company for gamers, to produce a certain kind of product and compete in a certain way. We are listening very closely, and I think the best answer I could possibly give is I think we're going to answer that challenge in the fullness of time. We have to start somewhere, right? We are resetting our roadmap, and starting in Ultra 5 and Ultra 7 is a great place to start. A lot of people buy here, but I hope you see or feel that something is a little different, and that we are thinking differently about how to compete. And that will play out in some very interesting ways over the next couple of years.
What should I have asked you about Plus that I haven't asked you about Plus?
Two things come to mind. One, I still see chatter about why Intel did not produce, for example, a 290K plus. I see that a lot. And I think that says some pretty unfortunate things about the industry at large, that people just like default assume now that the upgrade is only 7 to 7 or 5 to 5 or 9 to 9, that there should never be a scenario anymore where you could stair step a mid-range product over the top of last gen's higher, faster product. Doesn't have to be that way. But it says something about the industry that people expect this. And so when we thought about what to productize and what we want to provide to people, we could have made an Ultra 9. We could have. We had the material for it.
Well, we know that video cards had the table of the spec. So the suggestion is definitely you had the part and then you chose not to make that part for whatever reason.
More appropriately said, we chose to put all of that benefit in the Ultra 7.
Yes, the Ultra 7 270K plus, no less. I'm having to get
That's right.
Having to get the tongue going ready for the video on that one. The pricing of those parts, bizarrely, had you done this a year ago or 14 months ago, would have been hooray, hooray, and throwing the pencils in the air with excitement. In a world of $2,000 graphics cards, $4,000 graphics cards, and $500 memory kits, you've alluded to this already, and SSDs for that matter. It seems ridiculous to say the pricing doesn't matter, but you kind of know what I mean.
It matters.
It matters, but there is now a huge separation between the enthusiast products and the money that enthusiasts pay for gaming PCs, and the people that want to get a PC for, call it $1,000 or less, around the price of a PlayStation 5, I suppose. And that makes me wonder about AMD, over a period of years, as you know full well, gradually ate into Intel's market share, and then there's a flip in mind share with the enthusiasts, maybe not in the mainstream public. So we have a thing where 2/3 of desktop PCs are Intel now, I believe, but about 95% of enthusiast PCs are AMD. Some huge difference like that, which in turn says that you have a significant uphill challenge to change the mind share back. Now, I know you're then going to say, yeah, and that's why we need the media to do it for us. But is that the challenge as you see it, or have I analysed that completely incorrectly?
I think you're in the ballpark. I don't necessarily agree with the percentages, but look, I completely understand that Intel has that users and reviewers alike want Intel back in the Halo gaming space. They want us to be, kind of more like Intel used to be in competitiveness in gaming. And kind of everybody working on these products now has been in the industry since the good old days. And we remember what it was like when you had the core wars and the megahertz wars and the gigahertz wars and the blah, blah, blah wars, right? Like, we get it. We were there. And wasn't that a fun time to be in the industry? Wasn't that fun?
To be young.
So we're trying to recapture a little bit of that, right? We're trying to get back to this Halo position, and it's gonna take time. But I'm 100% convinced that with the roadmap changes we have made over the next 5 years, that we are going back to the good old days. And that's all I can say. But we have a plan, and I'm like, for my own gaming machine that I'm sitting in front of right now, I want every single one of these CPUs that we're planning over the next couple of years. I want them personally for my gaming system.
That seems like
because I work here, but I want them.
That seems like an incredibly upbeat note to end on, and that is obviously now the applause line. However, I feel I cut you off previously. You said you had 2 points, and I feel you got to 1 and I cut you off. Was there a second point to make?
The other one that I would ask users to keep in mind, I know they're looking at the CU-DIMM technology and going, this is like $1 billion memory kit, 256 gigs. Okay. The thing that I want people to understand about this technology is when you add more ranks to a memory module, you eliminate penalties where the memory cannot read or write data because aspects of it are on refresh. And that is artificial latency. And if you can add more ranks to a module and outfit a gaming system with those modules, that internal reduction in latency could be very statistically significant in PC games, especially titles like DirectX 9, console ported titles, the esports titles that run on anything. Right? These are all very sensitive to latency from a software architecture point of view. And so even if quad rank or dual rank CU-DIMM seems like this unassailably expensive tower right now, it will not always be the case. And I do want people thinking about, or potentially even testing, the benefits of that, because there was like this very small blip in time before COVID where dual rank DDR4 modules were phenomenally inexpensive. And Reddit was exploding with like, I'm at the same speed and same timings, but how did my gaming get faster? It's because more ranks is lower latency. I want people to know that.
Does that also
apply? If they can't afford it now, just think about it in the future.
Does that also apply to online games? Does that yield a benefit there?
Absolutely does.
Because you were saying the binary optimization, you were saying does not apply, as I recall, to online games.
Not yet.
Okay. Okay. Food for thought. Thank you very much. I think I'm done. Do we have anything else to say, or should we wrap up?
I just would like to also just say, in how we're talking about, the future and what these products hold and the kind of the roadmap that we're going down is also think about how binary optimization plays into that as well. We've come out of the gate showing gaming titles that are out there. Rob alluded to, doesn't help online titles yet, but also with a lot of the Geekbench testing subscores that we have out there, there's a lot more that can be done with this when it comes to other maybe productivity and creator apps as well. So we're just at the beginning of this software optimization phase, and there is a lot more that can be explored in the future as well.
That's a passively voiced, there's a lot more can be optimized. Does this mean there's some kind of guarantee or commitment, or that you will be optimizing in the next months, or are we talking years, or as I put it, weeks?
Not weeks for that one out there, but we're not done yet. I can absolutely wholeheartedly say we are not done yet, and we don't want to be holding back any performance where we can be. So it's a lot's coming down the pike. Maybe not in weeks, but months, future product launches. We're not done yet.
Yeah. We don't have a specific release schedule for binary optimization. When we see it, we'll release it. That's the other advantage of the platform performance package. We can kind of just do that whenever we want now. We're not reliant on some other distribution channel to do that for us. That's cool. But yeah, you're absolutely going to see us go after productivity, content creation, non-gaming cases. There are very massive gains to be had outside of gaming. We started with gaming as a choice because we thought that would be the most immediately understandable for people. But there is an entire world of performance out there trapped behind machine code, and it's significant.
Is it reasonable to say if you can gain a chunk of performance from binary optimization, that means the software wasn't that great to start with, considering there aren't that many makers of CPUs on the planet? If pick an example, if Adobe forgot to make software run well on Intel, that seems like quite an oversight on their part. Is there another way of looking at whatever gains you find from optimizations like that?
When it comes to things like Adobe out there, a lot of it's compiler based as well, and these guys are working and optimizing for what they have at their desk, for what hardware they have access to, and we're constantly coming out with new hardware. We're constantly, new cores, new frequencies. The hardware can move a lot faster, I think, than the software can. So what we're doing is we're just seeing where we can help out, where we can optimize there. When it comes to things like hardware profile guided optimization, we had people like Chaos V-Ray trust us to integrate our ICX compiler in there. And that's asking a lot for companies to do, to completely overhaul their software system. So with things like binary optimization, we don't have to get that direct access to their source code. We're not asking them to upend, their baby, their moneymaker for their company. We're just able to help them out with, since we can move faster on the hardware side and they can move on the software side. So it's just optimizing for what they haven't been able to optimize just yet.
Yeah, there's definitely industry pressure here. It's not that they forgot to optimize for Intel. The reality is, the thing I have to communicate is that a lot of the time, vendors, for time pressure or money reasons, choose generic optimizations. They get to a good enough point on all the vendors, and any form of specialization, sorry, there's not enough time in the development schedule or the release schedule to support specifics. Or if it was ported from a game console, right? We have all seen suboptimal ports, or ports that only expect 8 cores to be sitting in that socket. And what if you don't have 8 cores in that socket? What happens then, right? So it's more like there are opportunities here because the realities of publishing and development pressure prevent these peak optimizations from occurring more often than not. And at least we've been able to build a tool that can claw it back or do the specialization that the developer could not afford the time to do.
Excellent. Thank you very much. That's beautifully clear.
Thank you, Leo.